Hello, in the previous video we have learned that the mass of a system is equivalent to the energy of the system. Because of this, as the energy of a system changes, its mass also changes. In theory, the total energy of the system when a proton and an electron is bound together to form the hydrogen atom is lower than when the proton and electron are free from one another. This is mainly due to the loss of the electrical potential energy when a proton and electron are bound to each other. But we also realized the energy difference is only 13.6 electron volt, so the corresponding decrease in mass is too small to be measured. So if even electrical forces cannot result in mass changes that is large enough to be measured, then what can? The answer is nuclear forces. So we have here 2 protons and 2 neutrons. We know that 4 of them are able to bind together to form the helium-4 nucleus. We know that the mass of an individual proton is this number, the mass of an individual neutron is this number. So if you add this to this plus another mass of a proton plus another mass of a neutron, we arrive at this number. But what is the mass of the helium-4 nucleus? It's measured to be this number here. Yep, you didn't see wrongly, huh? These two numbers are different. The total mass of these 4 individual nucleons is larger than the total mass of the nucleus that they have formed. According to the mass energy equivalence principle, this decrease in mass reflects a loss of energy of the system when these 4 nucleons come together to form the nucleus. It's not just the helium-4 nucleus. Every single nucleus, you find that the mass of the individual nucleons is always larger than the mass of the nucleus that they have formed. And the amount of decrease is called the mass defect. So why should the system lose energy when the nucleus is formed? Now from this point onwards, I'm going beyond the A-level syllabus because sometimes I think it's worth it to go beyond the syllabus a bit if it helps you understand what's required of the syllabus. Now, have you ever wondered how come the 2 protons in a helium-4 nucleus can come together so closely? Remember, there's electric repulsion between them. The answer is because there's an even stronger force called the nuclear force that exists between every pair of nucleons, not just between 2 neutrons, but also between every neutron and every proton. And it's this very strong nuclear force that binds all the nucleons together to form the helium-4 nucleus. Just like electrical potential energy is lost when a proton and electron comes together to form a hydrogen atom, you can say that in this case, nuclear potential energy has been lost when these nucleons become bound to one another. I think now is a good time to stress that while we say that mass is equivalent to energy, we are not saying that mass is another form of energy. Don't get the wrong idea that mass is a new form of energy, like kinetic energy, electrical potential energy. When a system loses mass, it's because some form of energy has been converted into other forms and those energy have left the system. And because of that, the system has less energy now, and because of that, the system will have less mass now. Take the example of 2 magnets coming together because of the mutual magnetic attraction. Let's say when they are far apart, the total mass is 2 kg. So when they are accelerating towards each other, what's the total mass? It's still 2 kg. Because even though some magnetic potential energy has been converted into Ke, the Ke is still with them. So the total mass is still unchanged at 2 kg. What about just after they have collided? The total mass is still 2 kg. It's because the magnetic potential energy which has been converted into Ke has now been converted into internal energy. Just after they have collided, the 2 magnets are very hot. But if you wait for them to cool down, when they have dissipated the heat to the surrounding, only then has the system lost energy. And only then would their total mass be less than 2 kg. Similarly, when nucleons come together to form a nucleus, in the process, some energy must have been released to the surrounding. The energy that has been released to the surrounding comes from the loss in nuclear potential energy. The energy released did not come from the mass of the nucleons, because nuclear potential energy has been converted into other forms of energy which has been released to the surrounding. The system now has lost energy. This loss in energy shows up in the mass defect of the nucleus. Get it? Okay, ta-ta!